everyone. At Hammer, our goal is to build an extremely adaptive flight automation platform for commercial drones. In this particular video, we're going to look at how we can use Hammer to construct different types of roof inspection missions, plan the flight, and finally fly it automatically so that we can collect as precise data as possible. So let's jump right in. So I've got the map sort of centered over here on a different types of roof we can try planning a mission on. So the first thing to start creating a roof inspection mission in Hammer is to really go into the mission menu. So if you go to the top right plus button over here and you tap that, you see all the different types of missions that are currently available in Hammer. And for this particular video, we're going to look into roof inspection missions. So the mission type we're concerned with is essentially the inspection mission over here on the top left. So if you tap that, Hammer's going to ask you how to draw a polygon. Well, to ask you to draw a polygon over the structure you'd like to inspect. And we've got a number of roofs here, so we can jump right in. So to mark the roof you'd like to survey, basically tap on the map, and Hammer's going to start drawing the points as you tap on the map. So right now I've tapped that point, tapped that point, and as you can see, I can create a polygon around the roof that I like to survey. Once I'm done, I can tap OK, and Hammer will generate an initial plan with some default parameters which can be adjusted very easily. So as you can see right now, the roof isn't quite covered properly, and one of the vertices is not exactly on top of the roof, so I can just hold down that vertex and move it to where I want it to be. So I can move the entire polygon in that manner and essentially have something that fits the roof quite nicely. One of the other things to bear in mind is that this isn't the only way to import a shape boundary inside Hammer. One of the things you could also do is to go into the settings menu over here, and you can import your own KML file for the roof. And once you do that, that would essentially bring up a menu, ask you if you'd want to do a roof inspection, and you'd be able to get your boundary that way. So going back to our mission, we've got the polygon set, we've got the roof inspection mission, and now it's all about configuring the mission. So if you see the gear over here on top of the mission, tapping that will bring up a menu that will allow you to adjust the different parameters for this mission. So to begin with, we've got the camera type. So this really helps in adjusting the calculation of the points where the pictures are going to be taken. As you might expect, there are different parameters that are being respected here in generating the mission plan, which is the overlap, the ground offset, and also the altitude at which you're going to fly. So let's go ahead and change the camera type. We've got a range of different cameras available inside Hammer. Most of them are DJI cameras for the moment, with the exception being the Sony cameras and some of the MikaSense cameras. But we can essentially select any camera, and you'll notice as we change the camera, the flight plan changes, even though it might be marginal because it's quite a small roof at the moment. So let's just go with the Mavic 2 Pro camera. Once we choose the camera, we hit done, and now we can sort of go look into some of the other settings that we've got to configure. So we've got the altitude over here, and that's basically the altitude from the relative to the takeoff point. So one of the things to bear in mind is that altitude for any DJI flight is relative to the altitude at the takeoff level. So if you were to take off from the roof, that would give you a different altitude as opposed to taking off from the ground. So we would recommend that you would go to the site and measure using the drone itself how tall the building really is relative to the takeoff points using either Hammer or DJI Go. And then once you have a good idea of the altitude you want to fly at, you basically set that over here. So you can use the slider to move the altitude, and as you move the altitude, you will notice that lower altitude means the points get more dense, as you need more overlap between them. And if you increase the altitude, the points thin out, as you can just see a lot more. One of the things you can also do is actually tap on one of these points that are being generated to open up the field of view of the drone from that particular altitude. So you can open up multiple different points and have a look at what might be included in the picture from that altitude. and you can close them by tapping on those blue points again. So that's quite straightforward. So you can adjust the altitude using the slider, as I mentioned before. You can also tap on the number and set the altitude. So let's say I want to set that to 40. So there you go, you've got the altitude set up. The next setting we've got is the ground offset. The ground offset is essentially a way to tell the software what is the plane in which you want to take the pictures. So this might be a bit tricky to understand, but I'll try and sort of explain. So the idea is that perhaps you have a roof that you want to survey, which is at a 20 meters offset from the ground, and you want to fly at 40 meters, with 20 meters being the offset of the roof itself. So the roof is at 20 meters and you want to fly at 40 meters. But you would want the points to be calculated for that 20 meters as opposed to ground, because if you've got a vertical structure that you're surveying. So what's important here is to adjust this value to include the height of the roof. So let's say the roof is actually at 20 meters. So we're going to add the value 20 over there. And the height we want to fly at is actually 50 meters. That gives us a nice pattern that takes into account the altitude of the flight and also the height of the roof, and calculates the points, the overlaps, as if the 20 meters was the ground. So I'll try to sort of explain this in a different blog post, as I believe that this is a concept that's best visualized. But you can think of it as taking the pictures in that plane at 20 meters as opposed to the ground, because as you can imagine, the building's got some height. So moving on, we've got the front and side overlap. So these are quite common parameters. You would find them in mapping missions as well. So you can adjust the overlap you'd want between pictures. So you can see as I reduce the overlap, the points get more spaced out as there's just more overlap between them. But you could also do the same thing with the side overlap, and you will see the horizontal lines change. And moving on. So one of the other ways you can actually check whether the overlap is correct is essentially you can, let's say you've got 50% overlap for the front overlap, and you can just open those two of these pictures out and you can see they overlap more or less by 50%. If I increase that number to all the way up to 83%, then and I open two of these pictures up, you will see that the overlap goes up significantly more as compared to earlier on. So I'm going to keep the overlap at 60% for this flight. Let's say side overlaps at 70%, and you've got a nice little pattern in there. The other thing that you can configure is the direction of the flight. So by default, Hammer is going to plan a flight that is along the length of the triangle, length of the polygon, to minimize the number of turns. But this may not be ideal for your flight scenario, as you might want to fly into the wind, or you might want to use the wind for your flights. So you can freely adjust the flight direction that sort of works best for you. So in this case, you can see the flight pattern changing as we change the direction. Well, let's keep it at 90 for this particular flight. And the next setting we've got over there is the camera direction. So you might notice that the blue points in the roof inspection mission also have an arrow attached to them. So the arrow indicates the orientation of the drone. So at the moment, the drone is going to fly this way with the nose facing south. It's going to translate without rotating, and it's going to fly backwards with its nose still facing south, and it's going to carry on taking those pictures in the same orientation, so that when you get the this is an inspection mission, and the goal is not to sort of create a map out of it, but rather to inspect the roof for any defects and to perhaps create a KML out of it with pictures or some other format that you might require. It's quite important to sort of survey it in the same orientation as you started the flight. So the camera direction is by default south, and you can adjust that if you'd like. We know that for some of the solar inspection work, which is not quite what we're discussing here, we're discussing the roof inspections, but for solar inspection it's quite important sometimes to orient the drone in a different way and to fly in a different direction. So In this particular example right now, we would be facing, actually the drone would be facing east, but would be flying south in terms of its navigation itself. So those are, again, settings that we can configure for the flight. Let's sort of say we're actually going to keep it in the direction of the flight, so 90 degrees for the camera direction as well. And then we've got the gimbal direction here. So obviously this really depends on whether you want some oblique images for your roof inspection. Typically a good idea, so you could do one flight that is completely orthogonal, and then you could have oblique images as well to really see some of the things that may not be visible from a top-down view. So let's change that to 70, and that obviously wouldn't change anything on the flight plan, because that's just something that will change on the camera. Will change the camera as you fly. But actually, like, for this flight, let's just keep that to -90, top down view. And the last setting you see on this list is essentially a reverse flight path switch. So this essentially allows you to configure whether you'd like to start, where you'd like the flight plan to start. If you look at the map, you see the start arrow here, which is currently pointing to, if I zoom in, it's pointing at this point. And if you were to sort of assume that the flight would go down in this direction and carry on backwards that way, and then back down, and then here, the flight would end basically at this point. So, but it might be that actually you're taking off for somewhere here in the park, so you'd want the drone to start the flight over here and then complete the flight over there. In that kind of a situation, you'd want to just hit that switch, and then you would see that the flight path is now reversed, so you can start in one corner and in the other corner. So that really depends on your environment, and I think it's best to decide on the site what might be a safer flight path or a more optimal flight path. I'm sure that, as a drone operator, these are things that most people are used to doing now, and I think the software should be able to help out with making these decisions. So let's keep that sort of at the original position for this flight, and that's basically it. So we've got the basic mission set up, and what we would want to do now is to configure some of the settings that are not specific to the flight, not specific to the mission per se, but actually specific to the overall flight. So I would tap on that button over there to open the overall settings, and a number of different things come up. So you see the location, which is already set, so we're not going to change that. There are going to be drone specific settings, so you've got what type of drone type you're flying. This is non-settable at the moment. It's essentially automatically set to the drone you've connected. At the moment we don't have a drone connected, so it's a simulation, which we're going to get to in a bit. The next setting is the maximum drone speed. So this one's quite important. So if you're flying a roof inspection mission, you'd want to you want to make sure that the speed is optimal. One of the things to remember, that since this is an inspection mission as opposed to a mapping mission, the drone is going to fly from point to point, stop, take a picture, and then carry on. So the flight speed is not incredibly important in the sense of avoiding motion blur or avoiding some form of camera trigger interval problems that you encounter in a mapping flight. And it's more to sort of understand what might be a good speed that you're comfortable flying in. We would recommend going for something between 12 meters per second to 15 meters per second, as you'd like to capture the data fairly quickly. And then moving on, you've got some of the other safety features. So we've got the go home height. So that's basically the height at which the drone, it's the height to which the drone is going to climb to before it returns to home after completing the mission. We would recommend keeping this 10 meters above the height of the mission. So if you've got the mission configured at 50 meters at the moment, so we can configure this to 60 meters. One of the things you will notice is that if you set this go home height to lower than the mission height, lower than the mission altitude, or 10 meters from it, a warning will pop up which will basically indicate that one or more of the missions on the map are actually higher or within 10 meters of the current go home height. So all you got to do is just make sure that it's at least 10 meters or 10 meters or more above the mission height. So you've got 50 meters over here, and we've got 62 meters here. 62 is more than 50, so we're good with the go home height. The next setting is to configure is the go home battery percentage. So that essentially tells the drone at what percentage should it start heading home. 30% is fairly common. You could set it all the way down to 10% if you're flying fairly close to the building, but we would still recommend keeping it somewhere between 25 to 30%, especially if you're flying bigger platforms, and it's just nicer to have extra battery on the way home. And we have some other sort of safety settings which are sort of not specific to the mission, but overall, what sort of altitude, what is the maximum allowed altitude for the flight, maximum radius allowed for the flight. This may not be super relevant to a roof inspection mission because you would typically be within a good distance from the building, so the radius is really just a way sort of to safeguard incorrectly setting the drone to go far away. So we're not going to go into those settings for the moment. They've got some other settings, for instance, what would you like to happen in case the drone loses connection momentarily. For a roof inspection mission, we would recommend simply continuing the mission, as the drone is fairly in line of sight, and you can observe the behavior, and the connection does restore fairly quickly. But you can, for more safety reasons, you could ask the drone to hover in case it loses connection to the RC, or you can ask the drone to start a go home sequence. So those options are pretty configurable, and you can just go into this menu and set that according to your requirements. And then there are three other options. So the first one sort of says whether you'd want the drone to go home after missions or whether you'd want to bring it home manually. We recommend going home automatically, but one thing to remember is that if the drone is within 20 meters of your home point, then the drone would simply start landing as opposed to going home. So we would recommend this option only if your mission is more than 20 meters away from your home point. Carrying on, we've got the obstacle avoidance. So a lot of the DJI drones and other drones have got proximity sensors now, and this option only allows you to enable or disable this option. This really depends on the sort of safety requirements of the mission. As you can tell from this particular mission, you've got some trees over here, and it's on one side, it's very likely that at 50 meters you're going to be higher than any of those trees, and they're not going to cause any trouble. But in case the trees are actually quite tall and the drone at this particular point detects them, it might actually stop and abort the mission, since it's encountered an unsafe area and would want the pilot to take control. So it really depends on whether your specific mission requires obstacle avoidance on or off. By default, we would recommend keeping it on. And the last setting we've got is imperial units versus metric. So by default, Hammer uses metric units, but in case you'd want the altitudes to be visualized in the imperial units, then you can just hit that switch and you'll see the height, which was 50 meters here, changed to 164 feet. You're going to switch back to metric for now, and that's it. I think in the post-flight, you can always export your flight logs through this button, which is just a setting conveniently available there. And you can import different mission files or KML files for the shape boundaries as I explained earlier. So that's the gist of the different settings that need to be done before the flight. Now, once you've got the flight configured and you've got your mission settings done and your overall settings done, the important thing is to save the mission. So if you go into that folder icon there, you can essentially tap on that, open a folder, and you can save the mission. So the best way to do that is to just tap on the save mission file. So if you click on that, you'll be able to save your missions, and you might want to give that a name. So if you just tap on the name itself, you can call it roof tutorial. So that's what we're going to call the mission right now. And if you hit done, that's the mission we've got. If you want to create a new mission, you can simply hit the button there, which is a new mission file. You click on that. I'm just going to ask you if you want to save the changes. You've saved the changes, and now we've got a completely blank canvas in which we can create a new mission, perhaps with a different settings type. Perhaps you would want to do an oblique mission after you do a orthogonal mission. So it's completely up to you, and it's essentially a blank canvas. But you can switch between missions fairly easily. So you could actually simply open the mission by tapping the blue arrow over there. So if you tap on the blue arrow, you've got the mission back, and you can tap to the other mission. Well, at the moment there's nothing in there. So one of the things you could do is that, let's say you want to do 2 roof inspection missions, but with a very specific difference. So you could copy this mission using the copy icon over there, and that would allow you to make that subtle change in the other mission. So if you tap the copy icon, we've got, there you go, we've got 2 missions now, and they look exactly the same at the moment. But we're going to go into the copy and we're going to change something. So let's say in the copy mission, and I've tapped that button there so that I've opened the mission settings. I'm going to change the, let's see, what can we change? So let's see, we want to do this flight actually at a lower altitude, just because we want to get more details in this flight. So let's say we want to do that at 30 meters. So we change that one setting, we go into the mission folder, we save our mission, and let's rename that to details. So you've got 2 missions configured now on the same area, and let's get rid of the middle mission because we don't really need it now. So I'm just gonna hit the bin or the trash can, as you might want to call it, depending on where you listen to this from. You can basically click on that and you'll have all these sort of bin icons that appear in the cross icons, and you can essentially just click on one and then you delete a mission. So it's quite fairly intuitive, and you can tap on the bin to disable the delete mode. And now you've got 2 missions configured here, and you can very easily switch between them by simply tapping, and you've got 2 different types of roof inspections that you can run. And that's it. That's all you need to know in terms of plan a simple roof inspection. One last thing that you'd want to do before you go out to the field and start flying is you would want to be able to actually simulate the mission so that you can confirm what is the flight path, the orientation of the drone, and some of the things that are quite important to visualize before you go out there and fly. So let's do that. Let's add a simulated drone. So to do this, first of all, make sure you're not connected. The hammer is not connected to a drone, to a physical drone, for this particular part. And what you do then is essentially click on the play button to start a simulator, and you tap OK, and hammer's going to ask you where would the home location for the simulation be. So obviously this is just a simulation, so you can pick whatever home location you would like. Let's say that we're going to actually start this particular roof inspection from somewhere there, and you can see that's the home location for the drone, and we tap OK, and once we do that, you will notice a drone is going to appear on the screen, and it's going to show you the field of view of the drone, and it's going to go out there and start doing the roof inspection. As the drone flies, you can also increase the speed of the simulation or decrease the speed using these buttons here. So if you can just tap that, that would essentially show you six times the speed of what the simulation or what the mission would look like, and that just gives you a better idea of what you might want to expect. And once the drone is done collecting that data, it's going to rise to its go home height and then go home. So that was fairly quick, and one of the beauty of having all these sort of modular components to Hammer is that you can actually go out there and sort of change things and see how it might behave in simulation. So now that we know that we can go into the settings, we can essentially just go into the settings menu, change the altitude, and press play to refly the mission, and this will do a completely different flight. We can actually go into the folder and open the roof tutorial with details, and that's going to load up the other mission. And again, we hit play, and Hammer's going to go out there and do the bigger mission with details. So that's fair. That's basically it. The only step we're missing is to be able to go out there and fly. We're going to make a separate video on how to what things to take care of when you do a roof inspection whilst you fly. But in theory, this is all you need to know to be able to configure a roof inspection successfully inside Hammer. So what you would do on the field is to essentially plug in your iPad to your drone and load up this mission and press play, which will bring up certain pre-flight checks, and then you hit fly. So that's it for this video. We are going to make more videos about different types of missions available in Hammer and how you can successfully configure them. And please let us know if this was useful in the feedback and comment section. And if you have any questions, we are always available at team@hammermissions.com. Thank you.